Hello GATE aspirants, welcome to part 2 of GATE Mathematical Physics series. Question number 1. Two matrices A and B are said to be similar if B is equal to P inverse AP. For some invertible matrix P, which of the following statement is not true? Determinant of A is equal to determinant of B, trace of A is equal to trace of B, A and B have same eigenvectors, eigenvalues. So for this, we can find out its eigenvalues. So for that, consider B minus lambda I, determinant of B minus lambda I. This will be equal to, on the right hand side we have P inverse AP minus lambda I. Now here we can multiply and divide by P inverse, we can multiply by identity matrix, that is P inverse P, and this can be written as P inverse AP. And since lambda is scalar quantity and I is identity matrix, we can write it as P inverse lambda I into P. Then we can take P inverse common on both sides, and in bracket we have A minus lambda I into P, and we are taking determinant on both sides. So this will be equal to determinant of P inverse into determinant of A minus lambda I into determinant of P, and this is equal to determinant of P inverse P into determinant of A minus lambda I, and this is identity matrix. So again this will be equal to A into lambda I. So that means both these A and B matrices, they will be having same characteristic equation. That means their eigenvalues will be same. So eigenvalues are same. Now trace of matrix is equal to summation over lambda I. So if eigenvalues are same, their summation will also be same. And determinant is equal to product of lambda I. So that will also be same. So they will have same determinant, trace and same eigenvalues, and eigenvectors will be different. So here option C is correct. Next, if a force F bar is derivable from a potential function V of R, where R is the distance from the origin of the coordinate system, it follows that. Now F is derivable from it, so del of V, that will be equal to force. So this is gradient of V, and curl of gradient is always 0. That means curl of F will be 0, so option A is correct. Next question. If 3 cross 3 matrix has elements such that its trace is 11, so trace is equal to 11, that means lambda 1 plus lambda 2 plus lambda 3 is 11, and its determinant is 36. So determinant is equal to 36. That means lambda 1, lambda 2 into lambda 3 will be 36. The eigenvalues of the matrix are all known to be positive integers. The largest eigenvalue of the matrix is. Now if we have to consider from the largest value. So if we are considering 18, then this sum is 11. So it can't be 18 or 12. If it is 9, then other two eigenvalues will be 1 and 1. Because 9 plus 1 plus 1, it will become 11. But then multiplication will be 9 only. So this is not possible. So we have to consider 6. So if we consider 6, then we have 11. So 6, 3, 2. So 6, 3 is 18, 2 is 36. So this is possible. So option C is correct. Next question. The unit vector normal to the surface at point 1, 1, 1 is. Now this surface is given by this equation x square plus y square minus z minus 1. Now gradient of phi, it will be 2x x cap plus 2y y cap minus z cap at point 1, 1, 1. So it will be 2x cap plus 2y cap minus z cap, and magnitude of it will be del phi. It will be 2 square plus 2 square plus 1 square under root. So this will be 4 plus 4, 8 and 3. So unit vector n cap is equal to del phi upon magnitude of del phi, and that is equal to 2x cap plus 2y cap minus z cap upon 3. So option D is correct. Next question. Consider a cylinder of height h, its height is h and radius is a. closed at both ends, centered at the origin. Let r bar is equal to xi cap plus yj cap plus zk cap be the position vector, and n cap is the unit vector normal to the surface. The surface integral over the closed surface of the cylinder is. Now surface integral r cap, r bar into n cap into s. This will be equal to, by divergence theorem, is equal to volume integral over del dot of r, divergence of r over d term. So let us calculate divergence of r. Now r bar is equal to xi cap plus yj cap plus zk cap, and divergence of r bar, this will be x, so that will be 1 plus 1 plus 1, so this will be 3. So this integral I is equal to volume integral over 3 into d term. So that is 3 into volume integral over d term. That means volume of this entire cylinder, and volume of cylinder is equal to pi r square h. So here area, here this radius is a, so pi a square into height is h. So 3 into pi a square h. So option B is correct. Next question. The solution, the differential equation, this differential equation is given, let us solve it. So this y plus 1 into dy is equal to minus of x into dx. So this will be y square by 2 plus y is equal to minus of x square by 2 plus c. That is y square by 2 plus x square by 2 plus y is equal to c. So y square plus x square plus 2y is equal to 2c. This can be written as x minus 0 square plus, this is y square plus 2y. If I add plus 1 on both sides, so let us add 1 on both sides. So this will be y plus 1 square. So y plus 1 the whole square. This is equal to 2c plus 1. Let it be some other constant c dash. Now this is equation of circle with different radii. So these are circles with different radii. Option A is correct. Next, consider the function f of z is equal to, of a complex variable z. Which of the following statement is true for the function f of z? So we have function f of z is equal to z into sine z into z minus pi square. Now if we have to find out singular points first. Now singular point will be when z minus pi square is equal to 0, that means z is equal to pi. This is the singular point. Now if we put limit z tending to pi here, if we put here pi, then this will be 0, and sine pi is also 0. So this will be of 0 by 0 form. So we have to solve this. So this will be limit z tending to pi, z sine z upon z minus pi square. This will be of 0 by 0 form. So let us use L'Hospital's rule. So this will be limit z tending to pi, z into cos z plus sine z upon 2 into z minus pi. Now again if we put z is equal to pi, then this will be cos pi is minus 1, so this will be minus pi upon 0. It will be of this form. So this is some non-zero finite value upon 0. So this z is equal to pi is a pole. And here it is order 1. So it is a pole of order 1. So it is a simple pole. So option D is correct. Next, consider this function, same function. Consider a counterclockwise circular contour z is equal to 1 about the origin. So this is our origin and radius is 1. The integral f of z over this contour is. Now we know our singular point is z is equal to pi. So z is equal to pi is our singular point, and it lies outside this analytic function. If it is 1, then 2, then pi will be on 3. After 3 it will be there. So this function f of z is analytic function. And for analytic function f of z dz, it will be 0 by Cauchy's integral theorem. So here option B is correct. So these were all the questions from GATE 2011 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.